In. Good evening, everyone. This is lecture number 6, refraction. We are dealing with refraction at curved surface. In the previous class, we had seen what happens when refraction happens at one curved surface. We had seen the pole of the surface, and we had also seen these two types of focus. Do we remember the two types of focus? Yes or no?
Yes, sir.
The first principal focus is the point where if you keep the object, the image forms at infinity. The second principal focus is the point where rays coming from infinity or parallel to principal axis, they actually meet. That is known as the second principal focus. You have to keep this concept in your mind because these things are going to come over and over again. The next point, the next topic that we are going to understand is lens, or if I say lens, what I actually mean by a lens is a thin lens. So that would be more appropriate that I write thin lens. Whenever we are dealing with lenses, we are not dealing with thick lenses. We are dealing with very thin lenses. Can anyone tell me what do you mean by a lens? What do you mean by a lens? Now, nobody.
Combination of two mirrors.
Combination.
Curved mirror. Curved mirrors.
Oh God, no. No. Mirrors. You are wearing a lens. Are you wearing a mirror? Someone of you is wearing a lens. It's not a combination of two mirrors, beta. Mirrors have got one of the end silvered. Your lens has got one end silvered. What will you see? Nothing. Please don't say that. Try again.
Transparent refracting surface.
What? Transparent refracting surface. Yes, you are on the right track, bacha. What? Transparent refracting surface. Remember, no one is going to ask you this. This is just for you. If ever a question comes and you get confused as to whether it is a lens or not, this is the definition that is going to help you out. What is a lens? Would anyone want to try it again? 2 is there. That number 2 that you said is there, but you said two mirrors. It is not a combination of two mirrors. It's a combination
of two curved surfaces.
Not two curved surface. That is again one thing that you must remember. So basically, what you need to understand and what you do write, a lens
Refraction of curved surface.
A lens is a piece of transparent material. First thing, it must be made up of a what?
Piece of transparent material.
With two refracting surface. It must have two refracting surface. A glass slab also has two refracting surface. Do we call it a lens? No. What makes it a lens? At least one is curved. Third point. One of the refracting surface must be curved. Fourth point. The refractive index of the material is different from the surroundings. Fourth point. These are the 4 points that you must remember when you talk about a lens. What are the 4 points? It must be made up of a transparent
material.
Number 2, it must have two refracting surface. Number 3, at least one must be curved. And fourth, mu must be different from surroundings. These 4 points, if all these are fulfilled, then we call that thing as a lens. Do we understand this? Yes or no? No or yes?
Yes, sir.
Yes, sir.
Everyone understand this? Everybody noted this down?
Yes, sir.
Okay. Now, as soon as you talk about lens, you must know there are two types of lens. You have been studying this from 9 or 10 standard. What are the two types of lenses? Tell me fatafat.
Convex, concave.
Convex and concave.
Convex and concave. How do you differentiate between a concave and a convex? You must know this. Yes.
Converging and diverging.
Converging and diverging. Anything else that you can add up with? Anything else? Converging and diverging. What are the types of convex lenses that we are going to encounter? Any idea on that? Okay, I hope you know this and you can quickly go through this by drawing small diagrams. One type of lens, the first type of lens is known as a convex lens. Convex lenses are converging lens. Why are they converging? Because they converge, yes or no?
Yes, sir.
You must remember this. No one is going to ask you this. They are thick at the middle. They are thick at the middle and thin at the edges. Do we understand this?
Yes, sir.
Yes, sir.
Okay. The first lens that we see is convex from both sides. It is double convex. Do we understand this?
Yes, sir.
The second lens is plane from one side and convex from the other side. It is known as plano-convex. The third one is concave from one side and convex from the other side, but convex is more powerful than the concave one. Therefore, this is known as concavo-convex. Do we understand this? How do you get this concavo-convex lens? Once you understand that mirror formula, once you understand the lens formula, you will understand it. Concavo-convex, one surface is concave, other surface is convex, but the convex one is more powerful than the concave. So effectively, it behaves as a converging lens. Do we understand this? Yes or no?
Yes, sir.
The other type of lens are known as concave lenses, which are diverging lenses. They diverge. They are thin at the middle. You can see middle part. They are thinner and they are thicker at the edges. Three types. One is known as double concave, which is the lens that most of the time will come in the question. Both the sides are concave. The second one is plano concave. One is plane, other is concave. The third one is convexo concave. One side is convex, the other side is concave. But here, the concave is more powerful than the convex. Therefore, it is known as convexo concave. Now, we might have this small doubt. So, if I look from this end, the blue end, it might behave as a concave lens. And if I look from here, or if the ray or light is coming from green side, it might behave as a convex lens. Similarly here, if light is coming from this side, it will behave as concave. And if light is coming from this side, it will behave as convex. Do you think that is what that happens? That if in front of light, the first surface is concave, the lens will behave as concave lens. And if the first surface is convex, it will behave as convex. That means if I look at a lens, if I look from one side, it may be concave. And if I look from the other side, it may be convex. Does that happen? Or from wherever I look, a concave lens always remains a concave lens. Whether I look from here or I look from here. Yes. Do you understand my question? Yes or no?
Yes, yes.
I
Yes,
had this
sir.
question when I was studying at your age. When I look from this side, it will behave as concave. The other side, if I throw the light, it will.
No, sir.
No, sir. Pakka, sir.
Yes, sir.
Yes, a concave lens always remains concave. So this lens, the pink lens, is a concave lens. Whether light comes from this side or light comes from this side, it will always be concave. Do we understand this?
Yes, sir.
Similarly, this green lens is convex. Whether light comes from this side or whether light comes from this side, doesn't matter which surface is coming first. If it is a convex lens, it is a convex lens. Can a concave lens become a convex lens and vice versa? Next question. We are going to get the answer to this question by the end of this class. May not be this, may not maybe the other one. Can a concave lens become a convex lens? Or can a convex lens become a concave lens? What do you think? Can I change the nature of the lens? If I can, how? Anyone? Can I change the nature of the lens? Can the nature of the lens be changed?
No, sir.
No, sir. A concave lens always remains concave, no matter what. No, it can be changed. Because there is a very important factor that comes into calculating into finding out whether the lens is concave or convex. It is the refractive index. And we will see what this refractive index does and how can you convert a concave lens into a convex one, or vice versa, a concave one into a convex one. Right now, have you understood? There are two types of lenses, yes or no?
Yes, sir.
Yes, sir.
Now, remember, let me ask another question. Can a concave mirror become a convex mirror? I asked you, can a convex lens become a concave? And I said, yes. Lenses can be changed. A convex one can become a concave. Can a concave mirror become a convex mirror? These are the two
No, sir.
questions that we'll try to answer. But first, what we did in mirrors, whenever we started with mirrors, we started with the nomenclature of the mirror. What are the things that you must remember about a mirror? There was a center, there was a pole, there was a center of curvature, there was a focus. Do we remember all those things? There was a
Yes, sir.
radius
Yes,
of
sir.
curvature, focal length. Similarly, we have similar terms in lenses as well. And the first term that is going to come to us is known as optical center. Optical center is the first term. Remember, if you just understand the meaning of these terms very correctly, that means you have understood the entire concept very correctly. Now, what do you mean by the optical center?
Center of lens.
Center of lens, yes. You can call it in a very simple term, the center of the lens. What is the speciality of this center of the lens? What is the special thing about the center of this lens? And I will show you a very elaborate diagram that tells us diametrically very nicely what is an optical center. It is definitely the center of the lens. And I have on one hand, I have a biconvex lens, and B, I have a biconcave lens. Now remember, the things that we going to study are going to come from this diagram only. Do you see this principal axis? Yes or no?
Yes, sir.
Remember, there was a principal axis in your mirrors. Yes or no?
Yes, sir.
Every refracting surface, whether it was a reflecting surface, it was part of a sphere. Yes or no?
Yes, sir.
Similarly, every refracting surface is also a part of a sphere. You can see here two refracting surface. If I call this as number 1, this becomes number 2. Do we understand this, bacha?
Yes, sir.
Now this number 1 is a part of a sphere. Do you see the sphere of number 1?
Yes, sir.
This sphere has a center, C1. Do we see this?
Yes, sir.
Similarly, we have the other surface. I'll call it number 2, blue one. I have the other surface which is also curved. That also has a center of curvature, C2. Yes or no?
Yes, sir.
Yes, sir.
and there is a line which joins these two centers. Do we see this line?
Yes, sir.
This line is known as the
Principal axis.
principal axis of this thin lens. Principal axis of this lens is the line joining the two centers of curvature. Whether you see it in a convex lens or you see it in a concave lens, it will remain same. Then you have this point O. Do you see this point O? This point O is the center of this lens. You can call it as the center of this lens, optical center. What is the speciality about this point? And the speciality is also shown in this very little diagram, very nice diagram. The speciality is also shown.
Light do not get refracted.
Light does not get refracted is not very correct. Light does not get deviated is probably correct. If the light passes through
Light
this,
passes through that point.
light passes through the part, do you see this light which is passing through this one? It passes through it undeviated. If I actually draw the bigger diagram, you will see that there is some sort of a deviation, but for all practical purposes, we can assume, we can think that whatever light is passing through this optical center is going straight. It literally goes like it does not get refracted. It does get refracted. In fact, it just gets deviated slightly. But for all practical purposes, we can leave that. It just goes undeflected like this. Do we understand this? So this point is known as the optical center, is the center of the lens. Optical center, what you got to remember is the center of the lens. Point number 1. Point number 2, ray goes undeviated. Through this point, if a ray falls, whether it is concave lens or it is a convex lens, the ray goes undeviated. That is the first heading, optical center. Then the second heading is principal axis. What is principal axis? Principal axis is a line joining
Center of curvatures.
C1 and C2, which are the centers of curvature. Do we understand this, everyone? Everyone, please raise your hands, because understanding these points, understanding these definition is the only thing that we have to do better in this entire class. If you can understand these definitions, voila, nothing nothing comes near to it, because that is all in this chapter. Understanding the definitions and understanding the small formulas that they have. Optical center and principal axis. Are we done? Can we move ahead in life? Life has to move forward.
Yes, sir.
The next point is principal focus.
Sir,
Yes, beta.
is optical axis perpendicular?
Optical axis is perpendicular to the principal axis. Good for pointing this one out. I should have drawn this. I should have told you this. Sorry for my, I just missed it. This optical axis is perpendicular to your principal axis. Absolutely correct. Absolutely correct. Anything else?
Nothing, sir.
Okay.
Sir, wait for 2 minutes.
Okay. Do you want me to rub everything, and so do you have a fair diagram?
No, sir.
Okay. I'll give you 2 minutes. Don't worry. This is the most important part, because if you understand the definitions, everything is just simple formulae. Put that formulae, get your answer, stay happy. I'll give you 2 minutes. Go through this. Any doubt, any sort of doubt, please ask me.
Completed, sir.
What about the other class? Are we done, bacha?
Yes, sir.
Okay. That takes us to the next heading, and the next heading is known as principal focus. Number 2, principal focus. Principal focus. And I would now give chance to you. What would be the focus of a lens? What would be focus of a lens? Yes. And I know that you can give me the answer. What is the focus of a lens? Yes, bacha. Tell me. What is the focus of a lens? You know the focus of a mirror. A mirror has one focus. What about the lens? Yes, my dear friends.
Point of intersection of diverging and converging rays.
Point of intersection of divergent and convergent rays.
Refracted rays.
Refracted rays. Okay. Not very convincing. Not very.
Refracted ray passes through a point.
This is what the first principal focus is all about. Every lens has how many focus? Or how many foci?
Two.
It has 2.
Two.
The first one is known as the first principal focus. The spelling of principal is wrong. It should be PAL. The first principal focus. And that was the last thing that we did in the last class. What is the first principal focus of any refracting surface? The same definition is valid for the first principal focus of a lens. If I place an object at the first principal focus, after refraction, the rays become parallel to the principal axis. That is the first principal focus. Do we understand this?
Yes, sir.
That is the case of convex lens, but in a concave lens, it is slightly different. Rays which are moving towards the first principal focus, after refraction, they become parallel to the principal axis. This is known as the first principal focus. Do we understand it now? I have told you this definition of focus in reflection, in refraction of curved surfaces, but still no one seems to remember it. Isn't it? You are saying all sorts of things, point of intersection of converging rays, diverging rays. No one is saying parallel to principal axis ever. Do we understand this? Because this is the last time I am going to tell you what is the first principal focus. Because after that, we don't have enough time to keep on coming to the same point. Do we understand this?
Yes, sir.
Yes, sir.
This is the first principal focus, and the best way to understand this is by drawing a diagram. And that is why I've shown you the diagram. Now, I've shown you the diagram of the first principal focus. There is also a second principal focus. There's also a second principal focus. There's also a second principal focus. What is that second principal focus? Now, please tell me. And I hope that you don't let me down this time. What is the second principal focus?
Incident ray which are parallel to the axis passes to the focus.
Which focus? Which focus?
Second principal focus.
Second principal focus, and that is correct. Rays of light which are parallel to the principal axis, you can see them. After refraction, they will pass through one point on the principal axis. That point is known as the second principal focus. In case of a concave lens, it looks somewhat different. It sounds somewhat different. Rays of light which are parallel before incidence. After refraction, they seem to be coming from this point. This point is known as the second principal focus. Do we understand this? Yes or no?
Yes, sir.
Yes, sir.
Now, whenever we talk about lens and we talk about the focal length of the lens or the focus of the lens, we normally do not specify which focus are we talking about. But even if we don't specify which focus are we talking about, remember, we are always talking about the second principal focus. So whenever in whatever formula that we are going to do, whenever I am going to say focus of a lens, I actually refer to which focus?
Second
Second principal focus.
Second principal focus. Second principal focus. Do we understand this?
Yes, sir.
So these are the important points. I'll give to them point wise. Just draw this diagram. Have you drawn it? Once you have drawn it, tell me. Then I will tell you the important points. And remember, all these important points are potential questions of your JEE. Are we ready? Have you drawn it? Yes or no? I've changed the screen. Have you drawn
No,
this
sir.
or should I go back?
No, sir. Go back, sir.
Go back, go back, go back, go back. Simon, go back. Do you remember? Do you know this, Simon? Go back. Go back, Simon. Simon, go back. This spelling is also wrong. It is PAL, principal.
Completed, sir.
Everyone,
Yes, sir.
class number 1, class number 2.
Yes, sir.
Okay, then we shall move ahead. And as I told you, we will write some important notes, important points about this principal focus. These are all gems and diamonds that you must remember. The first thing, the second principal focus is the focus that we are talking about. So second PF, second principal focus, is the principal focus. Whenever we talk about a lens, we are talking about the focus, we are talking about the second principal focus. Do we remember this?
Yes,
Do
sir.
you understand this? Okay. Point number 2, if mediums on both sides of the lens is same, then what? Then what? There is a term known as the focal length of the lens. Then the first focal length will be equal to the second focal length in magnitude that we are talking about. Why we are talking about in magnitude? Because there is a sign convention. Do you remember that sign convention?
Yes, sir.
Yes, sir.
Direction of incident light, this, that. Do you remember this? And
sir.
if you look at the two principal focus of any lens, whether you are looking at the first principal focus or whether you are looking at the second principal focus, If the first principal focus is on this side, the second principal focus is on the other side. Yes or no?
Yes, sir.
Yes, sir.
So if one of them is positive, the other one has to be negative. Do we understand this?
Yes, sir.
Yes, sir.
And that's why I put the magnitude ka sign. If medium on both the sides of the lens is same, F1 in magnitude will be equal to F2 in magnitude. Why I'm talking magnitude? Because of the sign convention, the direction of incident light is taken as positive. Do we understand this?
Yes, sir.
Yes, sir.
What will happen if the mediums are not same? What will happen if the mediums are not same? Yes, my dear friends, what will happen if the mediums
Focus
are not?
will be different.
Focal length would be different in that case. If the mediums are not same, focal lengths would be different in that case. And actually, if you go back, back, I had told you the ratio of those focal lengths. Yes or no? If
Yes,
one
sir.
side we have a medium of refractive index mu1, as you can see here, and on the other side you have medium of refractive index mu2, f1 by f2 magnitude wise will be how much?
Minus mu1 by mu2.
Minus we don't have to write because I've written a magnitude. So it will be equal to mu1 by mu2. Do we understand this?
Yes, sir.
Yes or no?
Yes, sir.
Please remember this. These are some important points that you must not forget.
Sir, where are F1 and F2 at?
Yes,
Which
beta?
side? Which side is F1 and which side is F2?
F1 is on the side of mu1 and F2 is on the side of mu2. You can take it that way. For a convex lens, it is drawn. Yes or no? Convex lens F1 is on this side, no?
Yes, sir.
Any doubt on this? See F1. Look at F1. Look at F1 here. So this side you have mu1 and this side you have mu2. Do we understand this?
Yes, sir.
Don't worry, we will, when we discuss the formula, the lens formula, the lens maker formula, all these things will come automatically. Don't worry. I'm just giving them as points. Do we understand this?
Yes, sir.
Yes, sir.
Do we understand this?
Yes, sir.
The next thing, which we actually discussed previously, is known as the, I think point number 4 is known as the focal length. The distance of the focus from the center of the lens is known as the focal length. Every lens can have two focal lengths, f1 and f2. Yes or no?
Yes, sir.
Yes, sir.
But which focal length are we going to use always in calculations?
Second principal focus.
This one. This is the one that we always use. Do we understand this? Yes or no? No, yes.
Yes,
Yes,
sir.
sir.
This is the one that you always use in calculations. Now, focal length, you can write, is the distance of the principal focus from the center of the lens or the optical center. So I can draw it here. This distance would be known as f1. Do we understand this, bacha? And
Yes, sir.
this distance would be known as
F2.
F2.
this distance would be known as f1, bacha. This distance would be known as f2. I hope we are getting somewhere, right? Focal length.
Sir,
Yes, bacha.
why we always use second principle focus?
We'll come to that. Don't worry. Right now, just understand it. We'll come to that. Don't worry about it. I'll tell you. Right now, just note it down. We are not that just gone still into the lens formula, lens maker's formula. Once we get into that lens maker's formula, we will understand it. Don't worry. Shall we move on in life?
Yes, sir.
Yes, sir.
The next point is known as aperture, and the more difficult questions that I have seen in JEE Advanced, not so in JEE Mains because this never comes in JEE Mains, is on aperture. Now, this aperture is the effective diameter of the lens. Similar to what it was there in mirror, this is the effective diameter of the lens. Do we understand this, bacha? This is the effective diameter of the lens. So if I draw a lens like this, okay, and that may not look like a lens. They may that does not look like a lens. So I'll just that looks awfully bad. And this might do. Okay, if this is the lens, if I have this diameter is known as the aperture. Do we understand this?
Yes, sir.
And remember, sometimes what is going to happen is you are going to polish it. One half is polished. What happens? Remember the intensity of image, how intense or how sharp you are going to see this image. Intensity of image is directly proportional to your diameter or aperture ka square. So if I polish it or if I darken it, your image is going to reduce in intensity. Do we understand this?
Yes, sir.
Yes, sir.
Yes or no?
Yes, sir. Noted, sir.
Have you noted it? Both classes?
Yes, sir.
Yes, sir.
Then the next thing is power of a lens. We had seen power of the mirror. Now we see power of a lens. Again, it is in diopters. And how do I find the power of the lens? Yes, I'll give you that chance. How do I find the power of a lens? Power of a lens, my dear friends.
Reciprocal of focal length.
Power of a lens is 1 by f. Focal length must be in meters. Or you can write it as
100 by F.
100 by focal length in centimeters. Then I will get the power in diopters. Do we understand this, my dear friends?
Yes, sir.
Yes, sir.
Remember, power, P power, for a converging and diverging. Converging can be mirror or lens. Diverging can be mirror or lens. For a converging medium, the power is always positive.
Positive.
For diverging medium, the power is always negative. Do we understand this?
Yes, sir.
Yes, sir.
That means for a converging lens is a convex lens. For a convex lens, the power is positive. Do we understand this? Similarly, for a concave mirror, the power is positive. Do we understand this, or this has gone about at saying bye bye? I'm going.
Understanding, sir.
Then you can write the opposite in the sense.
Sir,
Yes,
you didn't say the power of mirrors.
I told you the power of mirrors. Minus 1 by f.
Sir, no, sir. You didn't tell us.
Okay, you can write it now. I must have told you. You must not remember. Even then, you can write it now. For a diverging thing, For a diverging lens, concave lens, the power is negative. Similarly, for a convex mirror, the power is negative. You can write the formula of the mirror if you have not written, so I will write it again. Don't worry. This you can write it as PL. L standing for lens, power of the lens. You can write this as PM. M standing for mirror, minus 1 by F. Minus 100. Power of a lens. Power of a mirror. You can write it now. I'll give you 2 minutes to write this, then we'll move on in life.
Done, sir.
Okay. Everyone has noted this down?
Yes, sir.
Yes, sir.
Of both the classes?
Yes, sir.
Okay. Then we can move on to image formation by a lens. And I hope you have done this before.
Yes, sir.
Where is the image formed? In different cases. You must know all these cases by heart. Where the image is formed in what cases. Do you know in mirrors we have done this, yes or no?
Yes, sir.
Sir.
How many cases did we see in mirror? Let us go back into the mirror. Let us go back into the
Concave 6.
concave
Convex
6.
2.
Okay, concave 6, convex 2. Let us now come to the present. How many we are going to do here?
Concave 2, convex 6.
Concave 2, convex 6. Do we understand this?
Yes,
Yes,
sir.
sir.
Okay, so if you understand this, then you must also understand what is the first. What is the first location? Remember, for concave mirror, how did we start? What would be the first location? Tell me,
At
fatafat.
infinity.
At infinity.
Okay, well done. Where is the image going to be formed?
At
At
focus.
focus.
Array, which focus?
Second focus.
Okay, will
2.
it be real or will it be virtual?
Real.
Will it be diminished or will it be enlarged?
Diminished.
Will it be erect or will it be inverted?
Real.
Huh?
Erect. Erect.
Correct.
It would be erect. It would be erect. Real image erect.
Inverted.
Virtual image.
Array, this image is real or
Inverted,
virtual?
sir.
Real, no.
Real inverted.
So,
Diminished.
okay, that is case number 1. What is case number 2? Chalo. What is case number 2 then?
Beyond center.
Beyond center of curvature. Okay, well done. Where is the image formed?
Between F and C. F2 and C.
Okay, well done. Real or virtual?
Real.
Diminished or enlarged?
Diminished. Real inverted diminished, sir.
Third position.
at C,
Where is the image formed?
at C,
Real or real or imaginary?
real, real inverted same size.
Well done. And this is what that happens in the case of a convex lens. Same scenario, same everything. So the first case, we have already seen it. Yes or no? Can we go to it fast?
Yes, sir.
The first case is when the object is at infinity. Yes or no? Image
Sir,
is
can
formed.
you explain the points with ray diagrams?
But we don't have to do it. You can just write it like this. There's no point of drawing the ray diagram. You're not in 10th standard that I show you the ray diagram.
For remembering, can you explain us, sir?
Which one, beta?
With ray diagrams.
Beta, you just write it. You don't have to draw the ray diagram. No one is going to ask you the ray diagram. Okay? You just write it.
Sir, you explain for us to remember.
Yes, you can remember it. You have to remember it this way only, beta. You let us not waste time in drawing a ray diagram, beta. There are lots of things that we can do in that time. Okay? So let's not waste time here. If something is necessary, it's required, I let you know. Don't have to waste time in drawing a ray diagram which you can find in books, right? You just have to understand where the image is formed. That's it.
Not a problem, sir. Explain with ray diagram.
Yes, beta?
Explain with ray diagram, sir. Then we can easily to remember it.
I'll waste an entire class in drawing a ray diagram. Beta, it will make no sense out of this.
Not a problem, sir.
It's a problem because we'll not be able to cover your course. Then it's a problem. I hope you understand. I can draw a ray diagram, but that will not serve any purpose.
Take some more minutes, sir, class. Extend the class.
Okay? You want to see a ray diagram? You see a ray diagram, not a problem. I can draw a ray diagram. That does not hamper anything. The only thing is you will spend more time in doing things which are not required. So this is the ray diagram. See it. If it helps your cause, see it. So this is the ray diagram. See it. Draw it. Draw it. Object is at infinity. The image is formed at the focus. The image is diminished. It is real and it is inverted. You can draw it. That is the first case where object is placed at infinity. Draw it and let me know. Once you are done, we'll go ahead.
Sir,
The image is real. The image is inverted. The image is diminished. And the image is formed at the second principal focus, F2. That is what you need to remember this. Case number 1. Do it. Let me know when you are done, beta.
done, sir.
Let us wait for the other class, beta. Let's not go so quickly. Let us wait for the other class. Let them also finish it.
Done, sir.
Well done, sir. Then there comes the second case. In the second case, as you can see, case number 2, the object is placed beyond 2F. So we call it beyond 2F.
Sir,
You
once
don't call.
previous slide, please.
Okay. See the previous slide. Why it is taking so long for you to do this? Think you should have done this in your 10th standard. You did not do it. Ray diagrams. Chalo, draw it fatafat. Do it fast. Let me know once you are done.
Done, sir.
Okay, well done, sir. Let us move on to the next case. And the next case is the case when the object is placed between infinity and 2f. Or I can say it is placed beyond 2f. Beyond 2f. So from infinity, we are coming towards 2f, and the object is placed between infinity and 2f. So the image is real. It is formed on the other side, and as you can see, it is formed between O and 2f. This image is real. It is diminished and it is inverted. So it forms a real image. The only thing is the size is less than the object. When the object is at infinity, the size is very small. When the object is between infinity and 2f, that is beyond 2f, it is smaller than the object, not very small, but still smaller than the object. That is case number 2, object placed between infinity and 2f. Draw the diagram. The object distance, as you can see, is given as u. I hope you have noted it down. The image distance is given as v. I hope you have also noted it down. So note it. Once you are done, please let me know.
Done, sir.
Remember, you are drawing the ray diagrams for a lens, but exactly same cases happen in mirrors. The only difference is here the image is formed on the other side, there the image was coming on the same side. Rest all is same. Have we done this? Case number 2.
Yes, sir.
The other class, are we done, bacha?
Done, sir.
Done, sir. Then, sir, comes the next condition, sir. And the next condition is when the object is placed, in case of a mirror, it was placed at the center of curvature. In the case of a lens, it is placed at 2f on one side. You can see the object placed here at 2f on one side. The image is formed at 2f on the other side, and the image is of the same size. HO and HI both are same. Magnification is -1. Magnification is negative. That means that the image is real. If the image is real, image has to be inverted. So you see an inverted image of an erect object. The object is like this, the image is like this. This is case number 3. When the object is placed at 2f, one thing that you have to understand is when the object is coming nearer, the image is getting bigger. When the object was at infinity, the image was very small. As it is coming towards us, towards the lens, the image is getting bigger. At 2f, the image becomes equal to the object. Same thing happened in case of a mirror. When the object was at the center of curvature, the image was also at the center of curvature. I hope you remember it. Draw the diagram. Let me know once you are done.
Done, sir.
Done, sir.
Okay, what about the next case? What would be the next case? Where will the object come now?
Between 2F and F.
Between 2f and f, object will keep on coming closer. So you can see here it is 2f, here it is f. The object is placed between 2f and f, and this is the reverse of case number 2. Do you see that? It is the reverse of case number 2. In case number 2, object was beyond 2f, and image was between f and 2f. Here the object is between 2f and f, and the image is formed beyond 2f. Do we see this? So this case is the reverse of case number 2. The object is between f and 2f. The image is formed beyond 2f, and therefore the image is enlarged. It is now bigger than the object itself. The image is still inverted. The image is still real. This is case number 4. Note it down. Let me know when you are done.
Done, sir.
Anyone has done this?
No, sir. Done, sir.
What is the next case?
No,
It's
sir.
focus.
Where will the image be formed?
Infinity.
That's correct, and that is the case here. The object is placed at the which focus will be this?
First principal focus.
First principal focus. Image is formed at infinity. Image is very enlarged. Image is real. Do we understand this? In the image is formed at infinity, that case may not be so important, but yeah, image is formed at infinity. Do we understand this? Image is real and image is highly, highly, highly magnified. Highly, 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 highly magnified. This is case number 5, my dear friends. The object placed at the first principal focus. Give you 2 minutes to note this down.
Done, sir.
No, sir.
Okay, I'll give you time, don't worry.
Done, sir.
Everyone done?
Yes, sir.
What is the last case? Case number 6.
Between focus and optic center.
Between focus and optical center. Where is the image going to be formed?
Virtual image, sir.
Okay, this is how it happens. This is the only case in which you find the image to be virtual. Do we understand this? Image is virtual in this case. It is enlarged. Image is virtual and it is enlarged. This is the only case where a convex lens creates a virtual image. So convex lens can only create a virtual image when the object is placed between F and O. Do we understand this? The image would be virtual and the image would be enlarged. So convex lens can only produce enlarged virtual image of an object in only one case, when the object is placed between F and the optical center. It is similar to what we see in concave mirrors. In only one case, concave mirror produces a virtual image which is enlarged. What is that case? In which a concave mirror produces an enlarged virtual image.
Between focus and pole.
Between focus and pole, similar thing is happening here. Remember, there is a difference between lens and mirror. In lens, whenever the image is real, it is formed on the other side. In lens, whenever the image is real, it is formed on the other side. In mirror, whenever the image is real, it is formed on the same side because other side is virtual side. In case of virtual images, for a lens, virtual image is always on the same side. For a mirror, virtual image is also always on the other side. Do we understand this? Do we remember this?
Yes, sir.
Okay, so that is all about the different cases for convex mirrors. Now comes the cases for concave mirror. How many cases will be here?
2.
2. Yes, there are only 2 cases possible here. What is the first case that is possible here?
Object at infinity.
Object is at infinity. Well done. Where is the image going to be formed?
At focus.
At focus. Will it be real or will it be virtual?
Virtual.
It would be virtual. Would it be enlarged or will it be diminished?
Diminished.
It would be diminished, and that is all that you see here. When the object is placed at infinity, image is virtual, erected and diminished, and it is formed at the focus F. If the image is virtual, the magnification has to be positive and it is formed on the same side of the lens as the object itself. This is case number 1 for concave lens. I'll give you 2 minutes to note it down. On which focus is this image going to come? First or second? First principal focus or second principal focus?
Second, sir.
Second. Second principal focus, that is correct. Note it down. Once you are done, please let me know.
Done, sir.
Okay, everyone did it?
Yes, sir.
Then the next case, if the object is not at focus, this is how the image would be formed. At any other point you place the object, image is always in front of the lens. That means it is always virtual. It is always between F and the optical center. That means it is always diminished. At the same time, it is erect. Do we understand this?
Sir.
Yes, you can see my screen. Yes or no?
Yes, sir.
Okay, so where were we? Okay, we were discussing the second case. The object is placed anywhere else. You will always have an erect, a diminished image formed by a concave lens. Do we understand this? Have you drawn the diagram, everyone? Anyone is there in the class? Yes or no?
Yes, sir.
Yes, sir.
Okay. Please let me know once you are done.
Done, sir.
No, sir.
Okay, do it.
Completed, sir.
Not completed, sir.
Okay, take your time, take your time. Let me know when all of you are done.
Sir, 2 minutes are completed, sir. Completed, sir.
Done, sir.
Okay, shall we move ahead then? We are going to write some important points. And again, this is a revision of what we had done in the mirrors as well. You can write point number 1, a convex mirror, a convex lens. And in bracket, you can also write whatever is true for convex mirror, a convex lens is true for a concave mirror as well on similar lines. A convex mirror can form real as well as virtual image of real objects. Do we understand this? A convex lens or a concave mirror can form real as well as virtual image of real objects. If it is a real image, it can be m equal to 1, it can be m less than 1, it can be m greater than 1. So what do I mean by this? It can be diminished, it can be of the same size, it can be enlarged. All the three cases are possible. Do we understand this? Yes or no? Do we understand this, bacha?
Sir.
When the image is smaller than the object, when the object is beyond 2f, when the image is of the same size, when the object it has 2f, and when is the image enlarged, when the object is between f and 2f. Do we understand this? But if it forms a virtual image, the magnification is always greater than 1. It is always enlarged. Do we understand this? Do we understand this? Yes or no?
Yes, sir.
Then, and we will come to this case when we get into problems. For a virtual object, convex lens can form real images for virtual objects. For virtual objects, my dear friend, and we will get to those cases when we solve questions. For virtual objects, it can only form real images. Same is true for concave mirrors. Do we understand this, bacha?
Yes, sir.
There is one thing which a convex lens or a concave mirror cannot do. Can you tell me what is that thing that a concave mirror or a convex lens cannot do? Yes, What is one thing that a convex lens or a concave mirror cannot do?
Virtual image for virtual objects.
Well done. Convex lens or a concave mirror can't form virtual images for virtual objects. A convex lens or a concave mirror cannot form virtual images for virtual objects. Do we understand this? We will get to
Yes,
these
sir.
virtual objects when we do questions which will have more than one lens. Same question came in this year's of this year JEE Advanced. We will also solve those questions. There we will find virtual objects coming into the picture, and then we will be able to understand those virtual objects. Similarly, I can write 3 points for concave lens. Can you tell me what will be the first point for a concave lens? Have you noted this?
Concave lens can form only virtual images.
Let us start with the virtual object. Okay, let us start with the real object. Concave, have you written the first three?
Yes, sir.
Yes, sir.
So the black one is the concave lens. Concave lens for a real object can only make virtual images. We have seen that, yes or no?
Yes, sir.
The object is real, it can only make virtual image. What will happen if the object is virtual? Concave lens for a,
Can form real and virtual images.
well done, for a virtual object, it can form both real and virtual image. For a virtual object, it can do both. For a real object, it can only do one thing. One thing it cannot do.
Cannot form real images for real objects.
For a real object, can't make real image. Whatever is true for concave lens, the same is true for a convex mirror. For a real object, a convex mirror also cannot form a real image. Do we understand this?
Yes, sir.
Has everyone noted this down?
Yes, sir.
Well, then that brings us to an end for this class. In this class, what we have seen is we have started with the topic of thin lenses. We have seen what are thin lenses. We have seen the nomenclature of the thin lens. What is the optical center? What is the principal axis? What is the optical axis? We have seen the two focus, the first and the second one, and we have seen wherever we use the second principal focus. In the next class, we will go through the sign convention once again. We'll go through the lens maker's formula, the most important part of this chapter. Most of the questions are coming from that, and the lens formula as well. So stay tuned. Be in the class tomorrow, because if you miss that class, you probably miss the entire session. So see you there in the next class. Take care. Have a nice day. If you have any doubts, please let me know.